and a letter, a variable, and a number right next to each other, this number is called a coefficient. And when you see those two right next to each other, that means multiplication. So if we were to try to guess, we could just try guessing things that go in place of k. So numbers that 3 times some number would equal 63. I can guess and test and see if I can get close to that number. So let's just try 3 times 10. That's 30. That's not 63. So I need something a little bit bigger. I could try 3 times 15, which is 45. So I'm getting closer, but not quite there yet. So we can do that, and that's perfectly fine. But we also know of a more efficient strategy, which we talked about a few weeks ago in class, and that would be using the inverse operation. Inverse is another word for opposite. So we could use the opposite operation to rewrite some of these equations in a way that has k by it, or the variable by itself on one side of the equal sign. That makes it a lot easier to solve the problem if we have two numbers to deal with instead of a number that we don't know. So if we were to rewrite this first equation using the inverse operation of multiplication, the opposite of multiplication is division. So if I were to rewrite this as a division problem, I would write 63 divided by 3 equals k. And like I said, it's a lot easier. We can already do 63 divided by 3. Those are just numbers, and then that would tell us what k is. So 63 divided by 3, that is 21. And when we write an answer, we don't want to just write 21 because somebody that's just looking at your work may not know what that 21 is supposed to mean. And also, when you get into higher levels of math, you might be solving for multiple variables at the same time. So we always want to say that what that variable is. So 21 equals k. We could also write k equals 21. Both of those would be fine. Our second example is m divided by 6 equals 12. So we want a number, m divided by 6 equals 12. Again, I can guess and check different numbers and see if I can get something that's close. So if I did 60, I know 60 is divisible by 6. 60 divided by 6 is 10, so that's close, but not quite. So we want a number that's maybe a little bit kind of close to 60. That would be a good estimate. But if we were using the inverse operation, making a more efficient strategy, the inverse operation of division is multiplication. So if I were to rewrite this as a multiplication problem, instead of doing m divided by 6 equals 12, I could rewrite that as 12 times 6 equals m. 12 times 6 equals m. And 12 times 6, we know, is 72. So m equals 72, or 72 equals m.